to sketch the graph of a rational function, there are several key pieces of information that are going to help us graph it. And those include asymptotes, intercepts, and holes. All right, so let's start by simplifying this function as much as we can. Okay, so I'm going to factor out a 2 from my numerator. So I have m of x equals 2 times x squared plus 5x plus 6 all over x squared plus 3x plus 2. And then that can actually factor even further. So I'm going to have m of x equals 2 times x plus 3 times x plus 2 divided by x plus 1 times x plus 2. And the x plus 2's cancel. So whenever you have a factor that is repeated in the numerator and the denominator, the x value that makes that factor 0 will create a hole in the graph. Okay, so now that I've done my simplification, I now know that there's a hole in the graph at x equals -2. You take that factor, set it equal to 0, you solve, and you get x equals -2. There's a hole in the graph. Okay, so we know there's a hole in the graph there. And then I can find x-intercepts, y-intercepts, and asymptotes. So to find x-intercepts, we set the numerator equal to 0. 2x squared plus 10x plus 12. And we know this factors to 2 times x plus 3 times x plus 2. And so we're going to get x equals -3 or -2, but it's not -2 because there's a hole there. All right, so at -3, I have an x-intercept. So I'm going to put that down on my graph, x-intercept at -3. And then to find y-intercepts, we plug 0 into the function. So I'm going to take m of 0, and that would give me, if I plug zeros in for all my x's, I'm going to get 12 over 2, which is 6. So I have a y-intercept at 6. Put that on my graph. All right, and then asymptotes. Vertical asymptotes happen when the denominator is 0, unless there's a hole there, right? So my denominator is going to be 0 at -1 and -2. But I have a hole at -2. So my asymptote is only where x plus 1 equals 0 or at x equals -1. So I go to x equals -1, and I'm going to draw a vertical asymptote. Right, and then my horizontal asymptote is determined using a rule where I compare the degree of the numerator to the degree of the denominator. In this case, the two degrees are the same, which means my horizontal asymptote happens at y equals the ratio of the leading coefficients. So 2 is my leading coefficient on top, 1 is my leading coefficient in the bottom. So 2 over 1 is my horizontal asymptote at y equals 2. If the degree of the denominator is bigger, then your horizontal asymptote is the x-axis, the line y equals 0. And if the degree of your numerator is bigger, there's no horizontal asymptote. But in this case, they're the same. So my horizontal asymptote is the ratio of leading coefficients. So y equals 2. All right, so now my graph would look something like this, because I know it always wants to hug its asymptotes. So it's going to look something like this. go from my intercepts towards my asymptotes, except I have to make a little correction because there's a hole at -2. So at -2, I shouldn't have a line, any line there. It should be a hole. Let's see if I can make that a little bit better. Hole at -2. There we go. So there, that's a good sketch of our rational function.